Today in our video we're going to talk about mosaic plots. In order to talk about mosaic plots, we are going to look at an example here where a high school is deciding to change their mascot or asking about what the mascot should be. So here's the prompt. When the high school was built in 1969, the school needed to pick a mascot. The principal decided to have the students and teachers vote between three choices: Rams, Falcons, or Prairie Dogs. He took a random sample of students and a random sample of teachers. Get used to hearing those words, random sample. And the results of the survey are given in the table. So as you can see here, they break it down in terms of teachers and students. And then exactly, well, I'm going to grab the wrong thing there. I'm trying to grab a highlighter. They asked teachers and students, and then they broke it down by the response based on the animal. Notice what's in the chart. They give us percentages. And so this type of distribution, not because it's percentages, but because it's broken down by what each category of person, teacher or student, picked which animal, this is going to be what we're going to call a conditional distribution. Because it contains conditions. If they were a teacher, and did they pick ram? If they were a teacher, did they pick falcon? If they're a student and pick prairie dog, etc., etc. When we go to do our data display on this, because that's what our first portion of this this unit is about, is doing data displays. So we have a two-way table up here that does a conditional distribution. We're going to look at creating two bar graphs, and we're going to use three different colors for the bars, and you're going to see why we do that in just a minute here. Let's look at teachers to begin with. Down at the bottom, you're going to notice that we have our three animals, and then along the side we have relative frequency. Relative frequency again talks about the percent that is used to describe the people that answered a given answer. And so at the top here we're talking about the teachers, so we're obviously going to look at the first row of our chart here. And the Rams bar is going to go all the way up to 80%. So I'm going to draw myself a little bar here at 80%. Okay, and that's going to be, we're actually going to use blue to color that in. And you're going to see why in just a minute here. When we go over to Falcons, that is 10%. So I'll draw my line here at 10%. And I'll fill that in with orange. Prairie Dogs was 10% also. Draw my line at 10%. Okay. And I'm going to make that green. Okay. Switching over to the student side. Notice we have the same three categories. We have different percentages, which is important. And so when we do our students, the Rams portion was 30%. So let me draw myself 30 here. We're going to make that blue so we can compare apples to apples. Falcons was 60%, so I'll draw my line up here at 60. That will be orange. And Prairie Dogs is going to be in at 10%. No love for the Prairie Dogs as the mascot here. All right. So that was number one. Number two is complete the third bar graph by taking each bar from the teacher sample and stacking them. Use the colors to make each section. Do the same for the student sample. So this is what's going to be our stacked bar chart, and so our segmented bar chart. So teachers, we're going to have Rams, Falcons, Prairie Dogs. So Rams is going to go up to 80. Falcons is going to stack on top of that. And Prairie Dogs on top of that. And it should make sense here. That adds up to 100% because all of our responses are represented. I need to shade these in, so Prairie Dogs goes at the top. Our Falcons goes in the middle. Rams is at the bottom in blue. So check that out. That's a nice way to compare. Hey, we represented everybody because the bar goes up to 100%. And the width of our segment, or the height of our segment, tells us how many people actually answered that. In the same way, we're going to do that for the students. So the Rams goes up to 30%. And notice, the cool part about this is when we do this side-by-side comparison, it's going to show us representatively which population or which group answered what. Falcons was an additional 60, so that's going to go all the way up to 90. Okay, and then up to 100% is prairie dogs. Okay, so it's a little bit short there, but we kind of get the idea. Rams, and then falcons here. And you can see pretty quickly here what happens, which one was most for teachers, which one was most for students. Now, what we're going to do in this next piece is we're actually going to construct a mosaic plot because down below, let's see, according to data displays that we did here, which one appears to have the most support? Well, you look at the bars, right? So if we look at the bars, which one has the biggest bar? That's kind of what this is asking. And so according to the chart, so this is a stacked, so this one here is a segmented bar graph. Remember? So segmented bar graph. And over here, this is just a bar graph. These are just bar graphs. Okay? The question that they're asking is which one appears to have the biggest following. Which one appears to have the biggest one? So it appears to be the Rams. And they ask, why do you think that? Well, the bar, it has the biggest bar. So clearly it has the biggest bar when you compare the segmented bar graphs. Well, what does that mean? Let's drop down a little bit and kind of see, well, if it's that obvious, why are we talking about this? Let's just think about this for just a second here. So upon hearing the results of the surveys, the students argue that the decision was incorrect because 100 teachers had been surveyed and 500 students had been surveyed. So think about that for just a minute. The teachers wanted Rams because they had this overwhelmingly big bar, right? So an overwhelming number of teachers. So obviously we go with that. Well, if more students answered, which one is actually equitable to be the mascot based on popular opinion? That's where the mosaic chart comes in, and we're going to talk about that in just a second. Let's fill in this two-way table. If there's 100 teachers and 500 students, let's do the raw numbers of this. It was 80% Rams for the teachers. So in this box is going to go our 80% Rams if we had 100 teachers. So that would be 80. And the beauty of using these round numbers, right, is we can kind of go right at it. And so Falcons was a 10% for the teachers and Prairie Dogs was a 10. So of the 100, 80 answered Rams, 10 answered Falcons, 10 answered Prairie Dogs. When we compare the 500 students and the 30, 60, and 10%, I'm going to write those down just for reference. So this is 30%. This was 10%. No, 60%. And this was 10%. Those are just for reference. I'm actually going to erase those. Let's look at what that would look like. Well, 30% of 500 would be 150. So hopefully you begin to see where the discrepancy might come, why these students might be a little bit upset, right? 60% for Falcons would be 60 times 0.6 times 500, which would give us 300 here. 10% of the Prairie Dogs would be 50. Something we need to consider whenever we're transitioning from the relative frequency to the number is, do they actually add up? So is 150 plus 300 plus 50 actually equal to 500? Yes, that's actually equal to 500. 80 plus 10 plus 10 is 100. So now let's look just what the question is asking. Which one actually won? Which one should be the mascot? And so really what we're asking is, which one did the most number of people vote for? So with Rams, it was 230 total people. So 80 teachers, 150 students. With Falcons, it was 310. And with the Prairie Dogs, it was 60. When we consider those numbers, which one actually won? Well, it appears to be Falcons. When we compare that to our segmented bar graph, it's a little bit misleading because it seems like Rams would be the same. In fact, even if we added up orange plus orange and blue plus blue, it still appears that blue would win. But if we go by the raw numbers, that is going to be more representative of actually which one was voted in. So how do we represent this graphically? What we need to do is how many times greater were the students sampled than teachers? Well, it was actually, there were 5 times more students sampled than teachers. So how do we upgrade the third graph in number 1 to take into account the sample size? Here's what I'm going to do. Because it was based on percents, what I'm going to do for percents is I am going to replicate this single. I'm actually going to replicate it 5 times. All right. The reason why I replicate that 5 times is because each one of those bars represents 100 people. And so if it's 5 times, if their population was 5 times greater, I take their bar and I multiply it times 5. And so this right here is what's known as a Mosaic plot. A Mosaic plot takes into account not just the relative frequency, but also the population or the sample size of what we, the raw numbers or the sample size of what we actually answered. And so why should they make, what should they make the EK mascot? It's obviously the Falcons, because by area, it would have the most people. That's represented right here in this chart. Falcons were 310, the total number of people. Now, even though blue seems to be large up here, right? Blue seems to be large. By area, orange is going to be the largest based on the raw numbers of people that actually answered that question. So let's break this down. Today we talked a little bit about categorical data, right? And we're going to start to talk about quantitative data now as well. So let's outline a couple of things here. Categorical versus quantitative. Categorical versus quantitative data. It also could be variables, so data or variables. So categorical variables they take on values that are labels or names. For example, a falcon, ram, what's your favorite toy? If I show what your favorite toy is, you can't answer that with a quantity. You'd answer that with something that you label, like a slinky or a Rubik's Cube, something like that. So they take on values that are labels or names. Quantitative variables are numerical. So they're numerical in nature, and they measure a quantity. What is your height? What is your age? What is your shoe size? Things like that are quantitative in nature. So how do we display these things? We've already talked about a few data displays. Displays of categorical variables. So on the AP test, you might be asked to represent data using a categorical variable. So you're going to have to know how to construct these and make them meaningful, right? To scale, have labels, those sorts of things. You can use bar graphs, like we did up top. You can use side-by-side bar graphs. That's what we had yesterday, right, where you put them right next to each other. So we had two different variables, and we put them side by side. So side-by-side bar graphs. You can use segmented bar graphs. And our segmented bar graphs were the ones up top where we had them stacked on top of each other. So each bar, and this is important, each bar shows not necessarily the number, but the proportion. Shows a proportion of individuals in each corresponding category. So it shows the proportion of the individuals. For example, up top we had the percentages. That's the proportion. The proportion you get used to, proportion and percent meaning the same thing. So proportion or percent. Association. That's what we're going to be very interested in statistics, is what is the association? Is this data significant? Does the fact that we got this number actually mean something? So association in this case means if knowing the value of one variable helps predict the value of the other. So if I know, for example, if they're a teacher, what are they more likely to pick? If I know that they're a student, what are they more likely to pick? Those are the kinds of questions that we're going to answer throughout this course, is what data is significant in helping us predict what someone is going to do, or is it significant that someone picks something based on what our prediction models might be? So if we can do that, if knowing one helps me predict the other, then we can say the two variables are associated. So if we can use them to predict, then we can say that they're associated. I want to add one little piece down here, and it's about that last part that we did. Mosaic plots. The mosaic plot was, again, when we took the bars and we put them side by side, and the amount of bars that we used was based on the population, or the number of people that we sampled. So a mosaic plot is a modified segmented bar graph where the width is proportional to group size. Our group of teachers was 100, our group of students was 500. So the group size dictated what size our graph was. This is 1/5 as wide as this because there were 5 times as many students as teachers represented. Let's look at one of these in practice here under your Check Your Understanding. Again, in this video, a good way to do this would be to pause right here to try to do this Check Your Understanding on your own, and then come back and watch the explanation and check your answers. I'm going to roll right through it here, but a good time to pause would be right now. So, the following table gives the result of a random sample of upper-level students at Rocky Vista University, the Fighting Prairie Dogs. There you go. So, Prairie Dogs was not a popular mascot. Here we go, Fighting Prairie Dogs right here, along with a mosaic plot. What we have evaluated in the table here is our employment status, so currently working, not working, but have had a job, have never had a job, grade levels juniors and seniors. So, important pieces here to note. We have our key down here, so orange represents have never had a job. Light blue is not working, but did in the past. Dark blue is currently working. Part A says, calculate the proportion of juniors that are currently working, not working, but have had a job and never have had a job. We need to figure out some totals here. If I look at my junior column, I've got 14 plus 22 plus 15. That would give me a total of 51 people. And in my senior column, 30, 40, and 10 is 80. Notice, when I look over at my mosaic plot over here, which part of the plot appears to be wider? Senior appears to be slightly wider, right? The width is slightly wider because it represents 80 people as opposed to 51 over here. Not as obvious as our one up top, where we had 100 versus 500, but again, representative proportionally of our population size. So let's calculate that proportion of juniors. So, junior who are currently working. So juniors who are currently working would be 14 out of 51. That's approximately 0.27. Juniors not working, but have had a job. And you can kind of see how this goes, right? We're going through the process here. You might be thinking, oh, this is pretty easy. Why would I want to do this? Well, sometimes these charts get really dense and really kind of confusing. And so being able to pick out conditions and then finding the proportions that are associated with those conditions is really, really important, especially as we get down the line. We're going to talk about this the entire year. In the last unit, we're going to still be picking out from a two-way table conditional probabilities. This would be 22 out of 51, which would give us approximately 0.43. Our last conditional probability is juniors never had a job. Is equal to 15 out of 51, is approximately 0.29. Of note, when we add those three things up, they should roughly add up to 100%. Now we've rounded obviously, but we should have all populations or all pieces represented. We're going to do the same thing for the seniors. So seniors currently working. Seniors currently working is 30 out of 80, which is 0.38. Seniors not working but have had job is equal to 40 out of 80, which is 0.5 exactly. And seniors not working, or sorry, never had a job. That proportion is going to be 10 out of 80, which is going to give us approximately 0.13. Write a few sentences summarizing what the display in Part A reveals about the association between grade level and job experience for students. Let's look at that data display for a minute. So what are some of the things that we could say? We can look at they obviously want us to comment on grade level and their experience. So what is that going to entail? That means which pieces are bigger, which size or which squares represent more people. So we could say there is an association, like we talked about last time. What would it mean to have no association? Well, no association would mean whether you're a junior or a senior, the percentages stay the same. Did the percentages stay the same? Well, we can clearly see here that this was 0.27 versus 0.38. So they're not the same. So there must be some association between being a junior or a senior and whether you work or not. Again, 0.43 versus 0.5. Close, but different. And so we can say that there is an association here. What is it? We don't know. But what we're saying is it's definitely not no association. So what should you put down here for Part C? You need to comment on some things like this. There is an association between employment status. If there wasn't, they would be all equal. So there is An important thing in AP statistics is not to just say there is an association. You have to say between what and what. So you should say between employment status and grade level. Why is that? So knowing whether or not a student is a junior or senior impacts their employment status. Okay? So knowing grade level for example, a senior is more likely to what? Well, look at our percentages here. It's more likely to be currently working. Or not working but has had a job. Okay, a junior is more likely to have never had a job because they obviously have these statistics here where 0.29, the junior is more likely to have never had a job than the senior, but the senior is more likely to have been working or not working and have had a job or currently working. That's how we can use mosaic plots. So mosaic plots are used to help us display these relative frequencies and give us an idea based on the number of people that were sampled, exactly how many or how much, or what type of decision we can maybe make based on the number of people that answered using the size of the plot and not just the height of the bar as in those segmented bar graphs. So thanks for watching, guys, and if you have any questions, contact me, but we'll see you next time.